Hello and a warm welcome to the most epic journey in the universe, the life and death of stars. Every star you see in the night sky tells a story spanning billions of years, from birth in cosmic clouds to spectacular deaths that forge the very elements of life itself. Today, we'll explore the wonderful stellar voyage that connects us all to the cosmos. Stellar Journey, the Life Cycle of Stars. Chapter 1. Stellar Nebula, the Cosmic Nursery. Our story begins in the vast, cold depths of space, in regions called stellar nebulae, cosmic clouds of gas and dust that serve as the universe's star factories. These nebulae are immense, some spanning hundreds of light-years across, yet they're incredibly sparse, 1,000,000 times less dense than Earth's atmosphere. But within these seemingly empty voids lies the potential for thousands of stars. Gravity is the architect here, slowly pulling gas and dust together over millions of years. As material clumps together, gravity grows stronger, beginning an unstoppable process that will birth a new star. Famous stellar nurseries like the Orion Nebula, visible to the naked eye, are actively forming new stars right now. Cosmic maternity wards where the next generation of suns takes shape. As gravity continues its relentless pull, our stellar nursery transforms into something more dramatic, a protostar. This is a baby star, still growing and feeding from the surrounding material. The protostar phase is a time of incredible change. The collapsing gas heats up as gravitational energy converts to thermal energy. An accretion disk forms around the growing star, spinning faster and faster due to conservation of angular momentum, like a figure skater pulling in their arms. Spectacular jets of material shoot out from the poles, powered by magnetic fields that channel the infalling gas. The core temperature climbs steadily. 1,000,000 degrees, 5,000,000, 10,000,000 degrees Celsius. This phase can last anywhere from 100,000 years for massive stars to 50 million years for smaller ones. But there's a critical threshold approaching. When the core reaches about 10 million degrees Celsius, something magical happens. Chapter 3. Main Sequence, the Prime of Life. Nuclear fusion ignites. Hydrogen nuclei overcome their electrical repulsion and fuse together, creating helium and releasing tremendous energy. A star is truly born. Welcome to the main sequence, the longest and most stable phase of a star's life. Our Sun has been in this phase for 4.6 billion years and has another 5 billion years to go. Main sequence stars achieve perfect balance, hydrostatic equilibrium. Gravity tries to crush the star inward, while radiation pressure from fusion pushes outward. This cosmic tug-of-war creates stability that can last for billions of years. But not all main sequence stars are created equal. Massive blue giants burn hot and fast, living only millions of years. Sun-like yellow stars burn steadily for about 10 billion years. Red dwarf stars are so efficient they could theoretically burn for trillions of years, longer than the current age of the universe. In the core, an incredible process unfolds every second. Our Sun converts 600 million tons of hydrogen into helium every single second, releasing energy equivalent to 100 billion nuclear bombs. This energy takes thousands of years to work its way from the core to the surface, then just 8 minutes to reach Earth. Chapter 4. Red Giant, an aging star. But not even the most stable stars can burn forever. Eventually, the hydrogen fuel in the core runs out, and our star faces a crisis that will transform it beyond recognition. With no fuel left in the center, the core begins to contract under its own gravity. But here's where stellar physics gets fascinating. As the core shrinks and heats up, hydrogen fusion ignites in a shell around the dead core. This shell burning is incredibly energetic, causing the star's outer layers to expand dramatically. Our star swells to hundreds of times its original size, becoming a red giant. The surface cools as it expands, giving the star its characteristic red color. If our Sun became a red giant today, it would engulf Mercury and Venus, and Earth would become a scorched, lifeless world. Red giants become unstable, pulsating and losing mass through powerful stellar winds. For stars like our Sun, when the core temperature reaches 100 million degrees Celsius, helium fusion suddenly ignites in an explosive event called the helium flash. And it releases as much energy as an entire galaxy in just seconds, though most of this energy is absorbed by the star itself. Chapter 5. Final Destinies. A star's final fate depends entirely on one factor: its initial mass. The universe offers three possible endings to our stellar story, each more dramatic than the last. White dwarf destiny. For stars up to about 8 times the mass of our Sun, death comes relatively peacefully. The outer layers are gently expelled, creating beautiful planetary nebulae, glowing shells of gas that represent the star's final breath. Left behind is a white dwarf, a hot, dense core about the size of Earth, but containing the mass of our Sun. A teaspoon of white dwarf material would weigh as much as a car. Neutron star destiny. But for stars 8 to 25 times more massive than our Sun, death is violent. When the core can no longer support itself, it collapses catastrophically in less than a second. The result? A supernova explosion visible from billions of light-years away. These cosmic explosions are the universe's element factories, creating and scattering gold, silver, uranium, and all elements heavier than iron. The explosion leaves behind a neutron star, a city-sized sphere containing more mass than our Sun. The density is so extreme that a teaspoon would weigh 6 billion tons, as much as Mount Everest. Black hole. Destiny for the most massive stars over 25 solar masses. Not even a neutron star can withstand the gravitational collapse. The core crushes down to infinite density, creating a black hole. These cosmic monsters warp space and time severely. Think of black holes like cosmic bowling balls placed on a stretched rubber sheet. They create such an extreme dent in the fabric of space and time that everything gets pulled toward them. The event horizon is the point of no return, where space is so severely curved that even light, traveling at the fastest possible speed, cannot climb back out of this gravitational well. Chapter 6. Stellar Phenomena. The universe showcases stellar evolution through spectacular phenomena that push the boundaries of physics. Pulsars are neutron stars spinning hundreds of times per second, acting as cosmic lighthouses with beams of radiation sweeping across space. They're among the most precise clocks in the universe. How precise? The pulsar PSRB 1937 plus 21 spins 641 times per second, with such regularity that it loses only about 1 second every 10 million years. Some millisecond pulsars are actually more accurate than the best atomic clocks on Earth. This precision comes from their massive momentum. Imagine a city-sized object containing more mass than our Sun, spinning in the frictionless vacuum of space with a crust harder than diamond. Scientists are working on using networks of pulsars as a galactic GPS system for deep space navigation. Imagine using dead stars as navigation beacons across the galaxy. Binary stars perform cosmic dances, sometimes for billions of years. Provided they're close enough, one star can steal material from its companion, leading to nova explosions or even triggering supernovas. Planetary nebulae, despite their name, have nothing to do with planets. They're the beautiful glowing ghosts of dying stars, shells of gas illuminated by the hot white dwarf at their center. Chapter 7. We are made of star stuff. Here's our stellar journey's most profound truth. We are intimately connected to these cosmic processes. Every element in your body heavier than hydrogen was forged in the nuclear furnace of a star or created in a supernova explosion. The calcium in your bones, the iron in your blood, the oxygen you breathe, all came from dying stars billions of years ago. We are literally made of star stuff, the products of stellar alchemy that has been ongoing for over 13 billion years. When you look up at the night sky, you're not just seeing distant lights. You're seeing your cosmic ancestors. The stars that died long before our solar system formed donated the very atoms that make up your body today. The stellar journey continues all around us. Right now, new stars are being born in distant nebulae, while others are ending their lives in spectacular supernovas, seeding space with the elements needed for future generations of stars and planets. This cosmic cycle of birth, life, and death has been repeating for billions of years and will continue for billions more. Each star that lives and dies enriches the universe, making possible the complex chemistry needed for planets, and ultimately for life itself. We are not separate from the universe. We are the universe becoming aware of itself, made possible by the epic stellar journey that connects us all to the cosmos. The end. The stellar journey continues. So, thank you so much for watching this video. Please find the whole project on our website, angles.filifoc.cat, on page Anglès per a joves, subpages l'espace infinit. We have loads more fascinating contents on our canal English Cat YouTube channel. Please subscribe if you wish. Thanks again.